Hi, everybody. I'm John, and I'm here with Brian Cavalier.
Hi, everybody.
And as you can probably guess, we're here to talk about IoC and JavaScript. But first, let's just quick review. Who are we? We are basically 200% JavaScript guys now, but we started out as back-end engineers. I've got some background in Borland and .NET stuff, and Brian's from the Java camp primarily, I think. So anyways, but we're the two main guys behind the cujo.js architectural toolkit. And what we're going to be showing you today is using the toolkit, but some of the techniques, actually all of them, are things you could do without the toolkit. We just think it's a whole lot easier with them. So as I just mentioned, Cujo is an architectural toolkit. We prefer not to call it a framework. And it's got a lot of Spring-like concepts. A large part of our audience today is from the Spring world, and so you're going to see some things that feel familiar. You guys who are not from a Spring background are going to hopefully learn some new things, or maybe see a different way of doing some things you're used to doing now. But we want to make it clear that this is not a port of the Spring framework to JavaScript. This is very JavaScript-like. Brian and I have both become very big fans of the functional and prototypal roots that JavaScript has. But all in all, this is a collection of tools that you can either use individually or you can use together, and we're going to show you how that all works together. Cujo actually started several years ago as some ideas in our heads, but what really got it off the ground was a project that we were both working on a couple of years ago. This project at the time only had about 6 HTML pages, but it had hundreds of JavaScript files in it. And also, a very interesting thing is that we were composing the UI out of what we were calling view components. And view components were they were an HTML file, of course, a CSS file that's closely associated with the HTML, a JavaScript controller, some localization bundles, and very importantly, also a test harness that went along with it. Okay, so clearly with this many files and this many components that all needed to come together, using the traditional script elements to load the page was not only going to present a performance problem, but also just a dependency management problem. Well, obviously we try to concatenate these scripts together, but then manually trying to figure out what goes before what would be virtually impossible on an application this size, an application that kept growing. So the other thing that we learned is that the typical, the jQuery idea of, grab some nodes and do something with them also was not going to scale well to something this large. So obviously we needed something better. We needed something that was more architecturally sound. Brian put it really well here, and I'm going to switch over to Brian so that he can actually introduce us to some of these concepts.
Okay, great. So if you come from a background where you've worked in an IoC type environment like Spring on the server side, or Spring.NET, you know this. You know that Spring or some sort of IoC dependency injection base architecture can help you manage the complexity of an application as it grows. And JavaScript, as we're seeing, we're building larger and larger things with JavaScript. And we're not only doing that in the browser, we're also doing it on the server in Node and Ringo and other server-side JavaScript platforms. So things are really only going to get more complex from here, and we're going to be doing it in more environments. We're doing it in mobile. We're doing it in desktop. We're doing it on the server. So we need a way to manage this complexity. And, so can we take the lessons learned from an environment like Spring and apply that to these growing JavaScript applications that we're starting to build? Can we do things like build smaller modules that are easier to unit test? Can we separate configuration from the application logic? Can we separate the actual connections between these modules from the modules themselves? Can we split the application apart into tiny unit testable pieces and then glue it back together in a way that's maintainable, refactorable, easier to understand, easier to get a big picture feel for the whole application? And can we apply some of the nice things that we get from an environment like Spring? Like, can we declaratively create some stuff? Can we have a declarative language instead of a procedural language for doing things where a declarative language makes sense? Not everything, but the things where that would make sense. Can we automatically manage the life cycle of the components in the application so that we don't have to remember to disconnect event handlers to avoid leaks, so that we don't have to do other things like that to avoid leaks? Can we manage that application life cycle automatically? Can we do dependency injection? Can we do aspect-oriented programming? It doesn't make sense in JavaScript. So, these are all nice things. Do they apply, and can we do them? And we think that the answer is yes, and we've sort of built Cujo around these principles. But one big question is sort of right off the bat, what would this look like? And, if you write JavaScript, you probably don't want to go write XML. So, what could we do within the language that gives us a nice declarative DSL, allows us to do things like AOP, things like that, without having to write a bunch of XML or resort to something like inventing a new annotation format for JavaScript that would be, somewhat like Java's annotations. While they're wonderful, there's no infrastructure for that. In JavaScript, we'd have to invent it. So we'd like to keep all of those things, and in order to do it, in order to build highly modular applications, the first thing that we need is a way to build modules. And then we can talk about how to glue them back together. So I'm going to turn it back over to John and let him talk about step one in this process, which is how do you write modules in JavaScript?
Okay, great. Thanks, Brian. There are a couple of competing module formats out there. I say competing, but they actually can work together. The one that we chose for Cujo is called Asynchronous Module Definition, AMD for short. And the reason we picked it is because it's great for browsers. And of course, we're trying to solve browser issues. So I'm just going to go over this really quickly. There are lots of texts out there, articles you can find, and we'll have links at the end to learn more about AMD, but I'm going to just go over it very, very quickly right now. AMD really centers around one global function called define. And define at its simplest form looks like it does here. It takes an optional list of dependency IDs, that is, other modules that your module needs to execute. And it also takes a factory function. And so the define will execute this factory function just in time when your module is needed, but not before any of these other dependent modules are loaded. So it manages the dependencies for you. Here's a small example of an AMD module. This one depends on some other module called when. When is one of the Cujo libraries that handles asynchrony. And if you notice, the factory function also has a parameter called when. And so what the AMD loader will do is find this when module, wherever it happens to be, make sure it's loaded, and ensure that it's available before your factory function executes. And so it passes that when module in as the first parameter in this factory function. And then it's very important in your factory function to actually return something from the factory function. This thing that you return will be the representation of your module to all other modules that may need it. There's another standard that evolved somewhat simultaneously, maybe a little bit later than AMD started, but it's CommonJS Modules. And CommonJS Modules are quite nice in that they don't have the boilerplate around them, but they're not really optimized for browsers, as we'll see later on. So this is a very similar module. Actually, this module exports the exact same thing as the AMD module, but you'll notice that there are some what we call free variables. They're not globals. They're just available to modules, and each module has their own version of it. So this is very similar to a Java import statement here. Actually, I say very similar, but in the same vein is probably more likely analogy there. And we're doing basically the same thing. The loader or the environment is finding this module when, and then we're assigning it to a local variable, much like we were doing with the factory and AMD. And the way to export your module to other modules is by using this other free variable called exports. And you decorate exports with properties and functions, and that becomes the public interface to your module to the rest of the world. So CommonJS modules are great on the server, and AMD modules are great on the browser. So how do you write code that works on both? Well, before I mention that, there's Node has several extensions to the CommonJS modules format, and one of them being this module.exports notation. You can actually assign the entire module. You can say, this is my module by assigning to module.exports. This is really good for exporting a constructor function like I'm showing here, or for exposing just a single function as your module. And we like to use this notation a lot because it comes really handy for these situations. So this is what I was alluding to before. The universal module definition is a way to use a little bit of boilerplate to allow your modules to run in either environment. There are many, many flavors of UMD out there. This just happens to be one of our favorites. It works in all of the environments that we care about. This will work in CommonJS environments that have the Node extensions, and it also works in an AMD environment. And just real quickly here, the way it works is you can see we've got a function closure here, and we're injecting define. Now this is injected down at the bottom here. We've got our standard AMD sniff. This is the accepted AMD sniff to see if you're in an AMD environment, and if you are, just use define because it's already there. Otherwise, we create this this other function that looks like a define, and it accepts our factory, and then uses the module.exports to take the result of the factory function and expose that to the rest of the CommonJS modules. You can see we're injecting the require, and that allows us to use this notation. Now, what's interesting is that an AMD environment recognizes this special signature here where we have no dependencies, but we have parameters to the factory function. And it uses that to know that, oh, you're emulating a CommonJS module, so I'm going to inject the require, the exports in the module, free variables, the quote free variables. So this allows us to write code that works on both server and client. Actually, curl allows you to write naked, unwrapped CommonJS modules as well, which is somewhat unique. So we also like to do it that way sometimes as well. But UMD should work across all AMD browsers, this particular flavor, and all server-side environments that have Node extensions like Ringo. So I lied a little bit. There is another global in AMD. There has to be at least one more in a browser environment to allow the bootstrapping of the app. Curl exposes a variable called require.js, understandably, exposes one called require.js. And many of them also have a require variable as well. And curl doesn't expose that by default because it's a little bit problematic, especially for noobs, because the behavior of the require, the global require, isn't exactly the same as the local require. So we force the developer to when we make them go that additional step to expose it, so they know, that they're causing this ambiguity. So let's take a quick look at this bootstrapping. I'm going to open up my code editor here, and we're going to look at the index.html file for this application called Monty Hall. And I can give a quick demo of this Monty Hall application in a second too, but the most important piece here is line 15. You can see that this is a standard script element that's loading curl, but there's also this extra attribute. We're using an HTML5 data attribute to tell curl that this is the module to run to get the application bootstrapped. And require.js is called data main, and it takes a JavaScript file, not necessarily a module. The way that data curl run is a little bit different, so we've called it a little bit different name than require.js. So let's take a look at that really quickly. And again, you can see that this is a standard AMD module. And in this, we're just creating a configuration for curl, so the curl knows where is the root of our web application. Here's some interesting paths where to find things. And then we have several package descriptions. And these tell curl where to find things. And if we're accessing a package by its package name, where's the file we actually want to grab. We can also get other information in here in curl, including, is this package really written in naked CommonJS or not? This is where you would do that. And then at the very bottom, this is where the global variable, the global bootstrap variable comes in handy. And this is where we say, okay, we want to configure curl and then start off this application by running this file right here, this module. This module uses a special plugin syntax, which we'll look at in just a second. So plugins are a neat idea. So why not use this loading mechanism that AMD has, this ability to go find things and bring them in just in time as when they're needed by your modules, and use that for other things. Let's use it for HTML templates. Let's use it for CSS style sheets. Let's use it for localization string bundles. Let's use it for Google Maps. There's all sorts of things you can do it. There are actually some quite sophisticated things you can do it. You saw just a second ago that we're using that for Wire. It's a nice little shortcut to allow Wire to load some information for its IoC container. We can even load CoffeeScript or do feature detection with plugins. There are lots of plugins out there people have written. Well, one of the things we noticed was thinking back to that large application, and this is not a snippet of code from that application, but this is a snippet of code from Dojo. I'm going to pick on these guys because just because I can. But as you start breaking your project up into little tiny modules, something like this can happen. This is just ugly. All of these dependencies, and how to organize this on the screen. It looks kind of ugly. What can we do about that? How do we avoid the dependency hell when using modules? And so I'm gonna switch this back over to Brian and let him talk about it just a little bit.
Thanks, John. So what we saw in that at the end of that segment was sort of using small modules to the extreme, and we created a situation where we had this huge list of dependencies. Now, granted, the module in that example was quite a complex module, the Dojo editor, but still, it's not a pattern we really want to. We want to subscribe to a lot because if you've worked in an environment, like Java, you could liken that to importing a lot of concrete implementations and then using them directly in the code, which can make the code very hard to unit test because somehow you need to make sure all of those things are configured correctly in order to unit test the module you're working on, or you need to be able to mock all of them somehow. And if you're using new to create instances of them within your code, it becomes even more difficult. So the way I like to describe that situation is that, when we're thinking about software, a lot of times we think about it as a bunch of boxes held together by a bunch of lines. And when you use import in Java to import concrete implementations, or you use AMD to pull in lots of modules and tightly couple them, you're effectively putting those lines inside the boxes. You're letting the boxes themselves draw their own lines. And that creates some difficulty when you go to start testing and refactoring. It also makes it difficult to, say, reuse those boxes in some different sort of configuration where the lines might be different. You can't easily pull them apart and put them back together in a different way or reconfigure them, say, for different customers. So how do we deal with that situation? And here's a quick example that we'll walk through. This is an AMD module. You see the define at the top. It's a simple controller with a constructor that we're exporting a constructor function. And we've added to our dependency list one of Dojo's data store implementations, particularly the JSON REST implementation, which is a really great utility, but we've depended on it specifically. And then inside the constructor function, we're actually creating an specific instance of it, and we're passing in a hard-coded URL. So, you probably know that this is bad news because we've hard-coded the URL, but also we're creating the concrete implementation inside the controller. So, if we wanted to unit test this, we'd run into some problems. We might have to, for example, try to fool the loader, the AMD loader, into loading some fake version or mock version of JSON REST for us. Another approach would be to mock the XML HTTP request infrastructure that JSON REST depends on. And it just feels a little messy to have to do that kind of thing for unit testing. There just has to be a better way. So what we can do is apply some principles that we learned from IoC called dependency inversion, where we take the data store and we hoist it up to the constructor parameter. And this is a very common pattern. You've probably done it and didn't know it had a name. But this way, the controller, we remove the AMD dependency, so we no longer have to try and fool the loader, and we don't have to take the extra load hit to load JSON REST and then throw it away. But we allow the caller to supply the particular data store implementation that is needed for the situation. For example, in production, we might use a JSON REST store, so we might create one and then create our controller and hand it to the controller. Whereas in unit testing, we might create a Dojo memory store, which is basically just a hash map, and fill it with test data. So that gives us some more flexibility to reuse this controller in different situations. So it seems like such a simple thing, but it actually turns out to be quite powerful, that we've completely decoupled the controller and the particular data store implementation. And we now have a controller that depends on an interface, even though in JavaScript interfaces are implicit. They sort of still exist conceptually. And we've moved the responsibility of this drawing this line between these two components out of the controller. Like we can do that somewhere else now, and we can do it in different ways for different situations. Of course, that begs the question of where do we put that code? We have to write it somewhere. And if you've worked in a dependency injection environment, you know the answer. The answer is that we use the IoC container to construct the particular implementation of the data store that we want, to configure it how we want, and then inject it into our controller. And so we've taken the responsibility of drawing the line and given it a proper place. What you're looking at here is an AMD module, but specifically it's what we call a wire spec. And this is very similar to a Java+Spring application context that you would write in XML, except this is written in JavaScript object literal notation. So this is what we feel like a declarative dependency injection language would look like in JavaScript. And we could feed this to wire, and it would do a few things. It would create a controller for us. It would load the module, create an instance of it. It would do the same thing with the JSON REST store. It would load it, create an instance of it, configure it with a target that points at the URL we have specified here. And then it would inject that as a property onto the controller. So all this configuration is now done externally to the modules. So the modules don't need to know anything about each other. And the controller becomes much easier to unit test because we can substitute. We could write a unit test in plain JavaScript that substitutes a fake data store. Okay, that sounds pretty interesting. Let's see where we can go with it. Obviously, working with the DOM in a browser is a necessity. So we tend to do the same thing with DOM nodes and DOM events that we just saw with the data store, and that is we tend to put the lines inside the boxes. So here's a simple example. We've got some view module that depends on a DOM library. You know, pick your favorite DOM library. But we've got a concrete dependency on it. And in the constructor, we're doing something similar. We're calling by ID and passing some HTML ID and presumably getting back a DOM node. And we have two dependencies here now. We are dependent on the API of the DOM library. Now, they're similar across things like jQuery and Dojo/Query and others, NW Matcher, whatever. But they're not identical. So we could get into trouble here by depending on this API if we ever wanted to switch. And we've hard-coded in an HTML ID, which instantly means that we should not have more than one instance of this item view ever on the page at one time, which is pretty limiting. You know, you can imagine a situation where you might want to put more than one type of view in an application, or create a testing view that shows multiple ones of these things in different configurations. So that's pretty limiting. So what can we do to get around that? And basically, we can apply that same principle. We can hoist the DOM node out of the constructor to its parameter and allow the caller to pass in the DOM node. And now, item view is no longer dependent on the particular DOM library that we might be using. It's not dependent on any CSS selector, an ID, or anything like that. So to unit test this, we could pass in some fake DOM node. We don't have to mock the DOM library. We don't have to put a fake or a mock HTML page in place in order to be able to unit test this. So we've kind of accomplished the same goal. We've made item view a little bit easier to unit test. Now, can we do that in a similar declarative style as we saw with the data store example? And the answer is yes. Wire has plugins for dealing with the DOM. We basically treat the DOM as a first-class citizen in a dependency injection environment because, that's what web development is about. We need the DOM. So here is a simple example. We've got an item view component. We're creating an instance of the module we just saw, and to its constructor, we're passing something, this $ref thing. We're piggybacking on a proposed standard called JSON referencing, which allows one part of a JSON document to reference another part of the document or a different document entirely. And we're sort of piggybacking on that proposed syntax, which uses this $ref property. And so we're saying, I want to pass in a reference to the DOM node whose ID is item list. And this DOM bang prefix is provided by the plugin that you see at the bottom, the wire DOM plugin. And this plugin lets you do various things with the DOM declaratively in wire. And we have several variants of that. So wire DOM works with query selector all and modern browsers that support that. We have wire sizzle, which uses the sizzle selector engine, which is the engine inside of jQuery. So if you need backward compatibility to IE6, you can use wire sizzle instead, and it provides the same set of abstract functionality that wire DOM provides, but it uses sizzle to implement the details. And we have variants for Dojo and jQuery also. So if you're already using jQuery and Dojo/query, you don't need to give that up. You don't need to use a second selector engine. We'll just use that. Wire Dojo DOM, for example, is a thin wrapper around Dojo query. Wire jQuery DOM is a thin wrapper around jQuery's selectors. So we've configured our item view with our DOM node via dependency injection. That's a good first step. A lot of times what we need to do is connect to events on DOM nodes. It wouldn't be a very interesting application if we didn't do that. So here we've got a module that does it sort of the way of importing our concrete dependencies again. This time we've got two. We've got a DOM selection library and a DOM events library. And we're using that in the constructor to bind a particular event type, a click, to a particular node, on a particular node, the button, the one with the ID, the button, and bind that to our controller's add item method. So we've just sort of made things worse here, right? We've depended on more things. We've got a hard-coded event type and a click. So if we wanted to add different listeners for different types of events, we would have to modify this view file. We've depended on the HTML ID, the particular DOM selection libs API, and the DOM events libs API. So these may not seem like huge dependencies until you go to unit test this thing, and then you really have to think about how to deal with these. Or you go to refactor it, and changing the event type, for example, or changing the ID, could create a mismatch with the HTML. Or if the HTML changes, it could actually break this view. So can we do that? Can we solve that problem in a similar way? And here we're refactoring this controller that we just saw that was doing the event hookups. And instead of importing a DOM selection library and a DOM events library, we have no dependencies. And our controller constructor is very simple. It's basically a do nothing. And we've got an add item method that accepts a DOM event. Okay, so we've slimmed this down, but we've created that same question. Where do the DOM event hookup and the DOM selection happen? And the obvious answer is going to be we're going to do that via the IoC container. So here we have an example of what it looks like to do this kind of thing. You notice at the bottom we've got two plugins in play now. We've got wire on and wire DOM. And you'll notice we have Dojo and jQuery variants of the on plugin as well. Again, if you're using Dojo or jQuery, Viz will just piggyback on those and use their Dojo on or jQuery.on facilities. So at the top, we've got this item view root component, and we're using our DOM referencing ability. We're using a different reference resolver this time. Instead of DOM bang, we're using DOM.first, which uses query selector all, or whichever query selector engine like Dojo or jQuery you're using, to give you the first element that matches the query, the CSS selector on the right, which is any item with the class item view. So give me the first element with the class item view. So we've switched from IDs to classes. Hey, that's a good thing. And then we've got our controller. We're creating an instance of it. No constructor parameters, so I can use this more compact shortcut syntax here. And then we're using this newly provided keyword in our DSL. It's provided by the wire on plugin, on. And we're declaring that any click on a button with the class add that occurs inside our item view root node, call controller.addItem. And as you'd expect, the DOM event will be passed through there. So now we've taken that out of the controller, and we are doing it declaratively here in the IoC container, so that controller now doesn't really care about what type of event happens. It just cares about the fact that the event did happen, and hey, now it's time to add an item. And that's really what the controller is about. So that's nice. It really let us slim down our controller. It lets us potentially connect the controller up in different ways without modifying it or re-unit testing it. Could we do the same thing to allow JavaScript components to interact with other JavaScript components? And again, the answer is yes, using something called synthetic events, where we allow JavaScript object methods to act like events. And this lets us hook two JavaScript components together without them having knowledge of each other. So here's a quick example. Our controller that we've been looking at, let's assume that it's from some simple shopping cart application. And now we want to add a new view component. And it's going to be, a simple counter that sits in the upper right-hand corner that tells you how many items are in your cart while you browse the site. And let's say it has this increment count method. And what we want to achieve is every time you add something to your cart, we want to increment the count. Now, we could use dependency injection to do this, and that would work out pretty well. So we've got our controller here being declared, creating an instance of it, and we are injecting an instance of the cart count view, which we've created down below. Let's assume it's a simple component whose constructor takes no arguments. So now controller has, this cart count view that it can access, and so it could call within its add item method. It could call increment count directly on cart count view, but that might not be the ideal solution, because now controller is dependent on the increment count interface, right? It's dependent on that method name. And it now depends on cart count view, this.cart count view existing. So to unit test this now, we've added a mock requirement, right? We have to mock cart count view in order to unit test our controller. And thinking ahead, there might be other times where we would want to increment or decrement the count view. And by hard coding those into the controller, that means every time we want to add some other thing that needs to react to adding items, we would have to change the controller. And when we change the controller, guess what? We have to reunit test it, and we probably have to mock more things. So if we wanted to add items, do other things when we add an item, we would have to modify the controller. And the reverse is true too. What if we want to increment the count at different times during the application? We would have to possibly inject this cart count view into multiple components. So that seems sort of less than ideal, and I think we can do better. So we could use synthetic events to do that. And the way that works is we'll create an instance of our controller, and then let's create an instance of our cart count view. And we have a new keyword here, connect. That keyword is provided by the Wire Connect module plugin that we're now using at the bottom. And connect is a very simple way to connect two JavaScript methods together. And this says, when controller.addItem is called, also call cart count view increment count. So when we add an item, the count will be incremented. And controller and cart count view now have no knowledge of each other. They can be unit tested independently. They can be refactored independently. But as long as these, and as long as these constraints still hold, that the add item method still exists, the increment count method still exists, it's still going to work. And we could, if we decide later we want to get rid of cart count view, we just can remove it from the wire spec. We don't necessarily have to delete the code. We don't have to change the controller. Thus, we don't have to re-unit test the controller. But you're saying to yourself, what if add item fails? What if it throws an exception? We can get a little bit more sophisticated. Wire has another plugin, Wire AOP. If you're familiar with aspect-oriented programming, this next section is going to look pretty familiar to you. So instead of connect, we're using this new word after returning. And this says, after add item returns successfully, call cart count view increment count. So if it throws an exception, nothing is going to happen. Okay, that's good. But what if it does throw an exception? Well, we've got another advice type that Wire AOP provides called after throwing. Again, if you're familiar with Spring AOP or Aspect-J, these work exactly like you would expect them to. So after add item returns successfully, we'll increment the count. After it throws, we'll use some other component in our application to show an error, right? We're just connecting to some different method. So we've effectively created a branch in our application logic here, purely declaratively. None of these components actually know about each other. So that makes them hopefully more testable. They can be rearranged within your application more easily. But we've still got some problems here that we'd like to do even better. And here's our controller again. And it's pretty simple, but I think we can do better. And one way we can do better is dealing with this DOM event parameter. The controller doesn't actually care about the DOM event. What it actually cares about is adding the item. And it needs some piece of information to identify what item needs to be added. And the DOM event really isn't that piece of information. It might be some item SKU number or some hash code that's stored in a DOM attribute, maybe a data attribute. So the controller has to do some work here in order to get that piece of information. It has to look at the DOM node, has to maybe look at the target node, search up the DOM to find some container node that has a data attribute, grab the value of that data attribute, potentially maybe even look that up in a hash table, and then finally add the item. So why do we want to do that work in the controller? The controller really doesn't care about any of that. It only cares about the minimum piece of information that it needs in order to add the item. And by the way, we would have to be able to mock all of that in order to test the controller. So what we'd really like to write is something like this, where we just get the item, we receive the item, and we send it off to the server or do whatever triage on it we need to do that the controller should do, send it to the server, and be done with it. Or maybe we receive an ID. Whatever minimal piece of information identifies the item here and the controller can use to do its work, that's what we really want. So how do we get there? Well, we saw how we could connect these things together. What if we could actually transform data as it moved across these connections that we're creating? And Wire allows you to do that. So let's take a look at this simple example. What we've done here is created a very small module that is simply a function. I'm using pure AMD syntax here, so I'm returning a function. And functions are really good at transforming data, right? They take an input and they return an output. So we're going to take advantage of that. We've got this module. It accepts a DOM event as its only parameter, and it's going to encapsulate the algorithm for finding the item or whatever key we need for finding the item that the controller really wants to work with. And once we have this function module, we can use it. We see we have a find item component here, and we're using Wire's module keyword to load the module that we just created. So find item ends up being the function that we just saw. And down in our controller, we've got this familiar on when a button is clicked within the item list, we're going to do these two steps. We're going to find the item, and that's our function, and it will receive the DOM event that was generated by the click. So find item will receive the DOM event and return an item, and that will get passed to the controller's add item method. So now the controller, for all it knows, will receive only the item, and it doesn't have to do all of this DOM event stuff itself. That algorithm is embodied in a separate module, which itself is unit testable independently of the controller. That would allow you to change that algorithm without modifying the controller, so you don't need to re-unit test the controller. You just re-unit test that algorithm. Okay, well, this is looking pretty good, but we're not quite done, because you're probably saying to yourself, no one writes a shopping cart application whose add item method is synchronous, right? There's going to be an XHR in there somewhere. So this is all going to go into asynchronous land very quickly, and you're right. And of course, the problem that creates is it forces us to put a callback function on the add item method, because we can't return anything anymore from add item, because the asynchronous XHR that's done within add item, we won't know whether it's successful or it has failed until a future turn of the JavaScript event loop. So the problem, of course, is that since returning and throwing become meaningless in an asynchronous operation, we can't use after returning and after throwing. So what do we do? Wire is promise aware. So you probably have heard about promises if you use jQuery or Dojo. You've used them most likely already, because Dojo /XHR and jQuery.get return promises now in their since like jQuery 1.5 and Dojo 1.6 or 1.7. Maybe it's been around longer. But promises are becoming more prevalent in the JavaScript world for managing asynchrony. Cujo itself contains a promise implementation, and Wire makes use of that. And in particular, we're talking about a proposed standard called Promises A+. And it is a minimum integration standard for promises. So lots of libraries like Dojo and jQuery, their promises can work with the Promises A+ standard. And since IoC is about gluing components together so that they can collaborate, if we have a standard for asynchrony, that sounds like a pretty good way to integrate components that need to operate asynchronously. So we could change our add item function in our controller to return a promise. And again, if you're already using a library whose XHR implementation returns promises, you can probably just return that promise. And what we'll do with that promise is we'll introduce some new advice types. Again, these are provided by the same plugin, Wire AOP. After fulfilling, we'll ensure that cart count view increment count is executed after the promise returned by add item fulfills successfully. So if the XHR succeeds, we'll increment the count. And similarly, if the promise rejects, we're going to show an error. So if the XHR ultimately fails, then we'll show an error to the user. So we've got the same branching going on, the same level of decoupling, but it's all happening asynchronously. So Cujo helps you do stuff like manage asynchrony in several ways, and we just saw one of them. There are a few others. I'm not really going to spend any time on them right now, but we saw AMD loaders. They manage the async dependency graph. We've got promise-aware AOP to help us manage the asynchrony. There are other ways that it can help as well. The takeaway here is that by being able to draw our lines without putting them inside the boxes and connect these components together in loosely coupled ways and focus the boxes themselves on the application logic, a lot of nice things happen. Things become easier to test. They become easier to refactor because we reduce the dependencies, we reduce the mocking, and we can transform data along the connections so that these things can be adapted to one another without having to put nasty code like traversing the DOM event to find the item inside the controller. And I'm going to turn it back over to John. He's going to describe some of the other benefits that this style of building an application can provide. Thanks,
Brian. Yeah, we're running a little tight on time, so we had a little demo. We're going to skip that, and we're just going to show you the code. So I'm sure no one's going to complain. Just quickly, I mentioned earlier that we found these view components very valuable in this large project, and one of the things that we really loved about them is that we didn't have HTML templates all over in one section of our code structure and our CSS over in another section and then our JavaScript all in another section. We co-located all the files for these views, and they actually truly became components when we did that, because then they could be organized and thought of and even tested and even designed as a single component. So I'm just gonna show you what that looks like really quickly here. This is an application that we did not get to demo, but one of the view components within it, maybe I can show it really quick. Yeah, I will. Let's do it.
Yeah,
okay.
Sure.
So this is the Monty Hall problem. This is a small application that illustrates that. And the Monty Hall problem is, if you remember the Let's Make a Deal game show, the contestant is presented three doors. They have to pick one. The host, Monty, picks another one, and then the contestant has to decide to stay or to pick another door. And so there's some mathematics behind this which tell you what to do to get your best odds. But I'm just going to run through it here. I'm going to click on door number 1, the host, pick door number 2, and I see that I do not want what's behind door number 2, so now I decide to stay or switch, and you can see down at the bottom here, a little bit of dynamic stuff going on, some instructions down here. I'm going to switch and pick door number 3 to see if I win, and yes, I won Jurgen. Just what I wanted. So just a quick little app here. You can see what's going on. And I'm going to hone in on these instructions down here. Very interesting piece of the component. Simple, but there's a lot of moving parts here. So everything to do with the instructions area, including a wire spec, if that has its own wire spec. It has its own internationalization strings. It has its own CSS. And it has its own template, which we can see is a div with a definition list within it. But most importantly, it has its own test harness as well. And this test harness is great because it can serve 2 purposes. One purpose is for location for our unit tests. We've got a little run tests function here that we can use to run some tests. I don't have... Oh, look, I have a 2 to put some unit tests in here. That's typical of me. Okay, so anyways, we could put our unit tests in here. But this has a second purpose, and I actually have it running here. We have some code that will run these test harnesses, and this is the test harness right here that runs and just encapsulates our instructions component. Let me just bring it up. It's in an iframe here, and it's right here. Here's our instructions view, and here is the template we saw, the definition list. Now, if you notice, the entire definition is all pre-rendered. We're using a technique called OOCSS states, which is really powerful, and these buttons right here will just alter the states, and we can pick the states, we can switch back and forth, we can click on things, and we can see that our component is displaying exactly the way we want it to. So you can see that the rest of the application is in here. We've just isolated this component, and we've done it very easily because we thought about this section of the application as a component, and we built it as one from the ground up. And another nice thing is if there's a whole Java backend and stuff, because we can mock any REST information coming back from REST or whatnot, that can easily be mocked and inserted into this test harness. And just a regular CSS HTML person could actually build this test harness because the code that's in here outside of these tests down here, which they could safely ignore, is really just a couple of buttons and then one function to toggle the class. Because again, we're using OOCSS states to manage the state of this component. So very powerful, very easy to now start testing your UI. And of course, this could be automated, put through something like Selenium or something like that. I'm going to skip past the unit tests. We've got unit tests for our other components as well. We use Buster to test those. Just quickly, here's what a sample unit test would look like, and we could easily run this through Buster. You could use QUnit or whatever to test these. Actually, I'm not sure QUnit does async very well, but Buster does, and we've had some people successfully using Jasmine as well. So that's the end of our presentation. Again, we just like to wrap up by mentioning the different pieces of Cujo. We were able to demonstrate a little bit of curl, which is our AMD loader, and we demonstrated wire and a little bit of when behind the scenes. But there's also meld to do AOP directly. Poly is a set of shims to bring up older browsers to ES5-ish standards, and also fill in some of the other gaps to de facto standards like XHR and set immediate. And Cola is our data binding library. And what's interesting is that Cola is actually doing the job that find item component did, and that is taking a DOM event or a DOM node and turning around and giving you a data item back so that you can write your controllers to just deal with data items. So that's it. Here's some great links to take a look at. This one, this bit.ly link here, is a link to some other links, lots of information about some of the standards we talked about today, and some tutorials. And of course, stay tuned on the blog at springsource.com to see lots more blog posts from Brian and I coming up in the future. So yeah, let's start taking questions.
Fantastic. Thank you. Okay, let's see. I have a couple of requests for clarification out, so we might get a few more. But let's start off with first question is: are CommonJS and UMD parallel frameworks to AMD, or do they work with AMD?
I'm sorry. One more time.
Yeah, no problem. Are CommonJS and UMD parallel frameworks to AMD, or do they work with AMD?
Okay, yeah, CommonJS is a different standard. It started from server-side development, so the environment is very different. AMD started from browser-side development, and those environments have very different constraints. So those are definitely not compatible standards. I'm gonna take that back right now. AMD has a way to allow you to wrap CommonJS modules. I showed that really briefly. UMD is a way to try and bridge the gap so that you could run a particular module in both a CommonJS or a Node environment and an AMD environment. And it does that with a little bit of boilerplate. And there are other ways to do that as well, but UMD is nice in that it doesn't require any changes to the environment. It's just a little bit of boilerplate, and then it will just work.
Great. Okay. Next question is Wire a framework like Dojo?
Wire is specifically an IoC container. So it's not a framework in how we tend to think of frameworks in the JavaScript world. It is not an MVC framework. It is not Dojo. It doesn't provide the breadth that Dojo provides in terms of utilities. It's focused on more of an integration activity. So it can parse this declarative style and create things, hook them together, and it can do that with just about anything because its plugin infrastructure is pretty rich. So, for example, if you have a plain old constructor function, it can create an instance of that for you. If you have an object, it can run object create on that and create a new instance of that for you. It has a plugin for digit, which allows it to work with the digit lifecycle. It can create instances of digits and then later destroy them for you automatically. So that if you're using more programmatic style digit and not relying on the HTML annotations, you don't get into the trouble of digits not being cleaned up. So it has these plugins that allow it to interact with other frameworks like Digit, like jQuery UI, although we don't have a plugin for that yet. We do have someone using Wire with jQuery UI who has written his own plugin for doing that. So Wire is more about integration, configuration, and connection more than being a traditional framework. It's architectural plumbing. That's what we like to call it.
Okay, great. Just a second. Sorry, lost my place here for a moment. Okay, there we go. Next question is there some type of exception handle? Oh, wait, sorry, that was answered. Apologies. Next question is there any way to define some sort of global after throwing? I may want to always present a dialog box by default or something similar.
I hope you don't mean global variable. There's certainly a way to do something with like a singleton or something like that. That's not actually a hanging off of the window object. Sorry, Brian. You probably have a better way.
No, that's okay. No, so we tend to not use globals in the traditional Windows sense in Cujo, and we're kind of adamantly opposed to them because we feel that the style of using something like an IoC container to manage the scope and the life cycle of objects and connect them that way is a better pattern than relying on globals. To try and specifically get at your question, it would be entirely possible to sort of set up some component that maybe used window.error, a global that already exists, to listen to all exceptions. There is no way right now built into Wire to say catch all exceptions ever and throw up a dialog box. It does have, if you're familiar with AOP weaving, it does have the ability to use AOP point cuts to attach advice across components, to cut across all your components using sort of a matcher query. So you could potentially attach an exception, an after throwing advice to every single method of every component. I don't know that I would advise that, but I think there are ways to accomplish what you're asking.
Okay. Next question is, are there tutorials, demos, or articles that talks about these techniques plus unit testing of JavaScript, CSS, HTML?
Yes, there are. We have some on the Learn It link, which is that on the screen now. I think people should be able to see it. There's a Learn It link there. I can say it. It's bit.ly/s2, as in Spring Source or whatever, s2-IOC-JavaScript.
Excellent. Thank you. Next question is, waiting for some clarification on that. Are all these frameworks production ready?
We do have many organizations that are using them in production. There are lots of big names using them in production. The only two that I think are probably still, well, they actually are being used in production, at least one of them is, Cola is. And Cola and Cram, we're still considering alpha quality because they're still somewhat volatile in terms of their APIs, et cetera. But even though they have the beta moniker on the other libraries, they're pretty well battle-tested, all of them. So.
Okay, so you guys are really going for a conservative beta moniker here, and
yeah, I think we call them beta until we feel like they're feature complete. As long as there's some things nagging at us and saying, yeah, this really needs this or this really needs something else, I think we're in our brains they're still beta. So.
Okay.
But that, yeah, again, that being said, they're very stable, very solid.
And one of the things about Cujo that might also be different from other frameworks, sort of harkening back a little bit to the question about Dojo, is that we've designed Cujo so that you can use pieces of it without using the whole thing pretty easily. Now, Wire requires more of Cujo, but if, say, you wanted to use just the AMD loader curl, you can do that. You can just go download curl, drop it into your project, and start using it. You don't need any of the other pieces of Cujo. If you want to start using promises, you can go get When and start using promises with When, and you don't need any of the other pieces. So, it's a little bit different from other frameworks in that respect, in that you don't have to necessarily buy in 100%. And they're architected that way, too. And their dependency graphs, each of the individual pieces, don't reach into the other pieces so that you can use them safely without having to pull in the entire world. So just a little bit of related information.
The exception there being Wire and Cola, which do rely specifically on some of the other pieces in Cujo.
Right.
Awesome. Thanks, guys. Okay. Potentially second to last question, possibly last question. How does this approach compare to using something like Backbone.js?
That's a good question. Backbone is, very popular, and Backbone is good at what it does. One thing that we've found in general with frameworks like Backbone or Ember or pick your framework of the week is that they're designed to do a specific thing well, and as long as you're building an application that looks like the kind of application that framework was intended to build, they work great. But what we found is that there's not every application fits that mold, and when you start trying to do things your way, you sort of quickly bump up against the bounding box of frameworks like Backbone, like Ember, and they make it. The more you try to go outside that bounding box, the harder they make it. The more difficult it becomes to write the application your way. And so one way we feel that Cujo is different, I'm not going to say that it's not opinionated, because every framework is opinionated, and we are certainly opinionated about some things. But we feel like the architectural level plumbing that Cujo gives you allows you to build an application in the way you want or need to build it. We feel like you could certainly use Cujo with Backbone, and in fact, that's been done. We have a couple of folks who have built applications using pieces of Cujo with Backbone and written Wire plugin to manage certain things about Backbone for them. So we try not to give you such a tight bounding box by providing more architectural level tools than build a specific application, build a specific type of application tools.
And last question, which I think, hold on, we got a bunch more coming in. Let's see. Oh, wow. Geez, a whole bunch more coming in. All right, let's move on then. Are you familiar with, oh boy, I'm going to mispronounce this, ERRAI, ERRAI? And if so, can you compare and contrast it against Wire, outside of the obvious fact that it's cross-compiled JavaScript?
I have not heard of it. Does that sound familiar, Brian?
I have not. I will definitely look it up after this presentation. Maybe what I can do is just give you, let you know that there are other dependency injection JavaScript libraries, frameworks out there. Some of them are very tiny. They concentrate on one specific thing. Obviously, we feel like Wire, gives you, because of its flexible plugin infrastructure, it really gives you the ability to do a lot more than other solutions that we've seen. But I will definitely take a look at ERRAI, ERI or ERI. So thank you, whoever posed that question, for that bit of information.
Yeah, interesting note that it sounds like that one's compiled. It's it's transpiled across compiled, whereas Wire is native JavaScript and it's also AMD, so it does not require a compile step in order to debug, which is nice too. So I mean, in certain situations, that's really easy to get started, anyways.
I'll see if I can get Ryan Dunkel's contact info for you guys out of the registrant list. Next question: How are you guys doing on time? You want to keep going for a little while? We still have 80. We've actually been growing. We still seem to have a number of participants left. There's 198 people left. So
cool.
if you guys can continue, it seems like we have an audience for it. So Let's see. Question was, I got the demo code, but I don't know how to set up the server side. Are there instructions to that? I seem to recall that question from the last session, and that the back end was sort of rests going back to Spring.
Oh, for the Monty Hall.
I'm assuming that's what he means when he says demo code is from the Monty Hall, but I could be wrong.
Yeah, actually, that should be using local storage, shouldn't it, Brian? Or is that a different branch? I can't remember.
We have in the Monty Hall code base, there are. This is kind of an interesting question because there are two. If you can bring up the main spec, we can actually show this for whoever asked the question, and for everyone else. This is kind of cool. If you see like around line 77. This is the main wire spec for the Monty Hall client application, and we have a server that's managing the game state for all the users running on Cloud Foundry. And on line 78, we're actually creating a client-side API for that server. And line 78 specifically is the actual API. That's the one that's going to talk to the server. So if there's no server there and we're using line 78, the application is obviously not going to work. But for testing it ourselves, we did this. We line 81 creates a game API component that is basically a fake. Go ahead and click through to that, John. You'll see that it itself is actually a wire spec, a very minimal wire spec. And then it's creating an instance of this fake API. And I'll let John click through to that also. And you'll see that this thing is a total mock, right? This returns simulated data that the server might return. And it allows us to actually play the game solely in the client using fake data, without having to run the server. So if you want to run this code yourself, what you can do is back in the app main, you can simply use line 81 instead of line 78, and that should get it working for you. It's kind of cool because, basically with one line of code, changed out our whole game API for a fake one.
And
so there you go. Yeah. So John just ran it. You might always win when you use the fake one. I can't remember. It might have a math.random in there somewhere to make it a little more interesting.
Excellent. All right, guys, thanks. And there was a couple questions about, hey, could you do a walkthrough of the demo app code once the presentation was done? So I think we've also, gotten two birds there. So thank you for that. Let's see. Next question is, what kind of effort do you think it would take for a large project that started with required JS and Backbone to convert it to using cujo.js?
We must get that once a week at least. It is possible. People have done it, and I think there's a couple of approaches there. If you can partition a certain part of the application off, like some new functionality, that's obviously an easy way to do it, to start from there. Another way to do it is to just start from the top and start using Wire as an application composition tool, and just get it to manage the life cycle of some of your top level components. And just try that. At that point, it doesn't make sense necessarily to use Wire to just do that, but it's a good place to get started, I think. What do you think, Brian?
Yeah, we've done that particular approach a couple of times, and it is a good way to start. Another, like John said, being able to partition your application into large-grained areas in your mind, and then look at each of those and say, maybe I could work on converting this one over here.
Right. Maybe it's got a minimal interface, minimal surface area with the rest of the app, and so it'd be an easy, clean break to take that chunk and convert it.
Right. And another thing a nice thing about AMD is that, curl and require.js both adhere to the standard. So while there are some differences, like in their configuration syntax, there are some minor differences, but the core API, the core configuration that you'll use is effectively identical.
Your modules are safe.
Right, your module format is the same. So curl and require, are almost interchangeable. So switching to curl would be a very easy thing, I think.
Excellent. Thanks, guys. We're almost there. We're at 23 after. Let's see. So I think one or two more good ones. Yeah. This architecture suggests that it would be possible to build a Spring-like enterprise app. But how would you possibly debug such a big, complex app with IoC aspects, etc., in JavaScript?
That's an excellent question. Debugging JavaScript in general is not super easy. So what some of the things that we've found that work well are one, unit testing, and we're big fans of that because we think that Cujo, well, one, it has obvious benefits, but two, we feel that Cujo allows you to unit test much more widely and much more easily, and so that if you do that, number one, you're going to be debugging less in the whole application, and building on that, the test harnesses that John showed allow you to test larger chunks of your application, an entire view, an entire widget, an entire section of your application, for example, in isolation without running the entire app.
Right. One of the things that we've done before is then, we also break up our application. Often our wire specs can be 2, 3, 4 levels deep. So there are wire specs that are actually compositions of other wire specs, and you can actually build the tests at multiple levels. And so you could, you have your unit tests at the bottom, and then more functional tests, and eventually work your way up to whole system-wide tests.
Yeah. I mean, to be completely honest, there are going to be, right now in the Chrome debugger, in all fairness, when you debug a wire application, you will see, within the stack traces, you will see some of the stuff that's going on in there. And that's going to be true of any framework, any substantial framework in JavaScript, is you're going to see their code as part of your current stack frame, and it's really no different for wire and curl and things like that. So it's going to be there. Do we see some room there for tooling support? Absolutely. And if we could make that happen, that would be really awesome. Conflating stack traces, things like that. Better tooling, that would be helpful, I think, to everyone.
Boy, well, that was a nice segue. That was perfect. There was someone asking about the GUI tools, and Eclipse and stuff like that. And I think it's worth pointing out that the editor that John and Brian have been using today is called Scripted, which is an open source JavaScript editor, and we would very much appreciate feedback on that editor and what direction to take it, as it's very early days. I think it's at like a 0.4 release, so very early days for that. But would very much welcome feedback, and debugging, obviously something people spend a lot of time doing. So would welcome your feedback on that. I think that's pretty much it. Okay. No, you answered the other question on AngularJS, and there was one gentleman earlier that never clarified, so I'm not sure if he's still on, but he asked a little bit about a compare contrast to jQuery, but I think he's gone, and I think you've also kind of done some compare contrast stuff. But since jQuery is so popular, if you have a short one on that, that would probably be great. And then let's close it out.
Sure. jQuery is it started life as an abstraction on the DOM to make it easier to work with the DOM APIs, and it was really, really good at that. They came up with a very simple, elegant way to deal with that problem, and they've added some things since then, like XHR. Dealing with style manipulation and things like that. So they've added a little bit more to jQuery, but we feel like those kinds of problems in the world we're living in now with web development are not the hard problems anymore. We're building larger applications. We're building more complex applications in JavaScript. We're moving large parts of our application, which used to exist on the server, into the browser. And so not only do we just have more stuff in the browser, we've got to think about things like, hey, let's not load every character of JavaScript into the browser on initial page load. Let's progressively load our application as the user navigates around. Let's be smart about, how we manage stuff like that. And those are architectural concerns, right? How do we structure the application modules, the business logic that we've moved from the server into the client in a way that's maintainable? And those are problems that have been addressed by communities like Spring and other enterprise-level application frameworks on the server, and they have a lot of ideas that we need to be able to apply as our applications get bigger and more complex in the browser. We're also doing the same thing in Node. So, these are a new set of problems that jQuery wasn't necessarily ever intended to address. So we feel like, jQuery is really good at what it does, but it wasn't necessarily intended to solve the same set of problems that we feel like Cujo is intended to solve, which are these more architectural type of problems: application composition, modularity, refactoring, unit testing, maintainability, those types of things. John, did you want to add to that?
That was pretty complete.
Okay, thanks.
All right, we are now officially at 30 minutes past the hour. Woo! Guys, thanks so much for staying on so long, and it's clear that, I think we pretty much managed to exhaust the question queue. Thanks so much. And if you wouldn't mind flashing out that links page one last time, that might be a good note to end on.
Yeah.
Awesome. Thanks, everybody. Great question.
Thanks, everybody.
We'll be posting a replay within 2 weeks on youtube.com/SpringSourceDev, which is our YouTube channel. And then also, please feel free to subscribe to our newsletter so you can stay looped in about future webinars. We've already got next month's webinars teed up. We're going to be talking about OAuth as well as Spring MVC tests. Please subscribe to the newsletter so you can stay in touch with us. And we're adding more and more content to that. We now even have tips and tricks of the month and stuff like that in the newsletter. So please do subscribe and stay in touch with us. Hope to see you on a future webinar. Thanks, everyone.